Welcome to this episode of Energy Radio, a podcast by CEM Engineering with the goal of giving you the knowledge and the tools and the power to manage your energy. Welcome to episode 17 of Energy Radio. On this episode, we have a celebrity in our midst. We have Mr. Dave Tykerobe, somebody that we have gotten to know. Martin's known for years, and we've gotten to know as a firm, and live in Niagara, and just kind of dropped in today, and we're really pleased that you're here, Dave. So welcome. Thank you for joining us.
My pleasure, Matt, and I'm welcoming the opportunity to kind of share some of my insights on energy.
Yeah, this is going to be fun. And before we dive in, Dave, maybe just a brief bio on kind of you and where you've been, what you're doing now, and then there's some great topics we could have here to kind of jump into.
Sure. So yeah, my background's about 3 decades in the energy space. I say that I started in the marine diesel space where pretty heavy bunker or other things were used as fuel. So each generation I keep cleaning up my credentials on the fuel supply, and now looking at hydrogen and renewable natural gas. But within that space, about 26 years was with Enbridge, many different careers within that organization. Some of the most gratifying was probably in the alternative and emerging technology space, making investments in next generation technologies that were up and coming, and that's really brought me to a greater focus on hydrogen, renewables for pipelines, electric microgrids, and that's led me to my own company, EEE Energy Advisors. And looking to do a fair bit on the policy advocacy front to help diversify really where and how we get renewable energy.
And with your new venture, EEE Energy Advisors,
yes.
Did I get the name right? Are you looking, like, who's your target? Who's the best people you can serve with your breadth and depth of skills?
I think there's a fair bit of work to be done on the policy front. So some of the industry associations, I think, are clearly interested in some of the help that I can bring. Additionally, engineering firms that want to diversify and kind of move from maybe their core business today to some of these up and coming solutions. That whole decarbonization of energy is growing in its visibility, and it's more than that. It's starting to become something that has to move mainstream, and so some of the ideas I have, bringing them mainstream, I can collaborate with those engineering firms.
Yeah, it reminds me, I was at IDEA last week, the International District Energy Association. They had their campus energy event down in Denver, so all the colleges, and just decarbonization was everywhere in every conversation. And what struck me was it's the right thing to do, but for them, the pressure is really acute because every year there's a new batch of students, and they're all really advocates for these social causes, right? And they come in with no frame of reference of what the university's been doing for 25 years. So they expect the world in terms of, why are you burning natural gas? Or in these land grant schools, why are you burning coal, right? And so that whole decarbonization thing is, I think, really hitting that campus sector first. It was just fascinating to watch over the course of 3 days. It's real for them.
It's real. I'm hopeful that we can adjust the dialogue actually and make it a broader discussion, because clearly it's something that if we stay too narrow as to how we think we're going to get to that future where we're without emissions or very low emissions, it's going to be a challenge unless we figure out how to bring more tools to the fray. And pipelines, instead of being something to oppose or something to be embraced as a key delivery channel for renewable energy. But we'll talk a little bit about that.
Yeah. Just before we move off of your time with Enbridge, I've always been intrigued by the fact that of the two kind of utilities, the gas and the electricity, at least from my purview, on the gas side, there was DSM was kind of always there, and which seems contradictory to a gas utility that they're trying to use less. And then, all the stuff that you've been working on and others trying to really diversify. I don't know if I've seen that. They're catching up now, but on the electricity side, they weren't as quick movers, I don't think, in terms of both conservation and also, kind of diversifying. Why do you think that is?
I think, I was very impressed in my time with the gas utility space. Their breadth, their scale, I think gave them a lot of flexibility as well. There was a time where, something that people wouldn't look at as innovative today, things like rental equipment programs, your water heaters.
Yes.
Grew into renting boilers and furnaces, rooftop makeup air units. The ability to take those platforms and say, right, it may not be as economical as people want, but when the right packaging with a rental program, I can bring that next generation of efficient technology to the forefront. The HVAC market for heating, ventilation, and air conditioning has changed immensely, but the utilities in the gas space did immense work to break down barriers to that next generation equipment. I think as well, the scale and breadth of their employee base gave them a lot of flexibility to say, right, our customers are going to benefit if we can make them more efficient. Keeping industrials in the area by making them more efficient was better than losing an industrial to an offshore production. And that's cascaded through their mentality as a utility, I think. And the electrics are getting there.
Yes.
But the sad state, I'd say, in at least Ontario where I live, and I think this is still mainstream in many of the electric domains, the politics gets far too involved. And it's tough for the electrics to say, all right, I'm going to chart a course between now and the next decade or two, because they get whipped pretty hard by the call it government of the day's priorities.
Yeah. The piece you had about customer service from the gas side, I'm so intrigued by that, because how you said it kind of has permeated everything. Like, the reality is it's permeated CEM because Martin started his career at Union and Union Gas, and all the learnings about, you call on your existing customers first and you try to serve them first, and you just the rhythms and the approach to customer service. I mean, that's so true. It permeated that culture, and by extension, to your point, they understood how changing the landscape would help their customers. That's why they did it, ultimately. So
and the reality is, in today's world of moving to a carbon-constrained environment, efficiency should be number one.
Right.
The reality is, as we bring different solutions forward, as the price of electricity or fuel goes up because of either its carbon pricing in one area, could be the renewable content in another, it could be the need to modernize the electric grid and substantial capital infusions adding to cost. By helping customers manage what they use and use less, they're going to manage their bill, but they're also going to be a better footprint for that environmental target that we're all aiming for.
Yeah, totally. So you mentioned kind of new and emerging technologies. Near the end of your tenure at Enbridge, you were very involved in this power to gas project. Talk to us about that.
Yeah, so power to gas is becoming more mainstream in different parts of the globe. Here in North America, still fairly new. But think of it as sector coupling in one way. In Australia, they'd call it hydrogen hubs. In Europe, sector coupling would mean convergence of wires, pipelines, transportation space. And the core of it is a technology called water electrolyzers. So DC electricity, water into a device that basically will split that water molecule into hydrogen and oxygen. In many cases, we just vent the oxygen to the atmosphere, but that hydrogen is now recovered. And if the supply of electricity is from clean or renewable supplies, you now have a clean or renewable supply of hydrogen. And the beauty is really in the flexibility of that once you have the hydrogen. You can direct that energy now to long-term storage by injecting in the natural gas grid. You can store it, bring it back to the electricity grid through existing gas-fired generators. You could use fuel cell stationary products to bring that back as electricity. But you can now start to target the transportation sector with more tools than just electric vehicles. So a fuel cell electric vehicle would have a fuel cell, small battery, but your supply is now hydrogen to create the energy needed for transport. And in heavy-duty trucking, in rail, we're seeing Alstom in Germany bringing fuel cell commuter trains, completely eliminating the need for overhead electric infrastructure for electrified rail. I think when you start to look at what I brought forward for Enbridge, they sent me out to find energy storage. That was the real mantra, and that's becoming a bigger need for today's economy.
Yeah.
It's often said if you like wind and solar, you're going to have to love storage.
Right.
To that I add that if you love storage, you're going to have to look at pipelines. And that's the next phase. We brought North America's largest power to gas plant at 2.5 megawatts to service the electric grid.
Yes.
It starts its life in what we call grid stabilization. Okay. As we bring more renewables, we get more variable supply.
Yes.
We have variable demand.
Yes.
You need to smooth that out in a second by second basis, or if you don't, you end up with a problem like the 2003 blackout through much of the eastern US and central Canada. And that grid stabilization is something the electrolyzers provide. You can add either more generation or take generation off, or you can add more load or take load off to provide the same stability.
So do you see it as a technology that plays in kind of these ancillary markets where there's different services they can sell that's not maybe energy?
It is very much one player in the ancillary service market, and that would be what that plant that we brought into service in Markham, Ontario is today providing.
Okay.
That second by second frequency control and grid stabilization. Co-producing the hydrogen, my hope is the next phase will be moving to taking that hydrogen, inject it into the natural gas grid, and now we are affording consumers vast, cost-effective, existing seasonal energy storage.
So let me unpack that for a minute. So you're saying that currently the project you did is only, the hydrogen is currently not a captured benefit. Its current only commercial benefit is the service it's providing to the grid?
So in the way that project will start under grid stabilization, it will store hydrogen for about 8 megawatt hours worth.
Okay, so there's on-site
storage.
Okay.
And in addition to the electrolyzer providing that grid stabilization through variable load, there's also a fuel cell that is also providing power back.
Okay.
In essence, the early ancillary service contracts were forcing just about all energy storage technologies to behave like a battery.
I see.
There's nothing wrong with a battery, but let's be honest, 2, 4, 8 hours storage, that's a lot.
Yes.
If you want to do a bit more, you do things like pumped hydro, compressed air energy storage, and even there, you're limited to hours or a couple days.
Yes.
People do not understand the vastness of the gas storage network.
Right.
So, few stats.
Yeah.
Peak day for the electric grid here is about 24,000 megawatts. In equivalent terms, the peak day for the gas grid is over 80,000 megawatts.
Wow.
That's 3.5 times.
Yeah. And today we have both electric and gas, but we have the infrastructure to support that. Underground, we have the infrastructure for 85,000 megawatts.
Bought and paid for every winter. It keeps the homes, heated. It keeps the factories running.
Yeah.
Now, why would we not use what we already have before we build something new? And that's where the power to gas becomes that sector coupling or that hub between wires and pipelines. I refer to it as a new intertie. We think nothing about building a connection to have electricity shared between Ontario and New York State, province to province, state to state.
Yeah.
Why would you not have a new intertie between your wholesale electric grid and your wholesale gas grid? And now you have all that storage available to you. And I need to touch on the costs of this.
Yeah.
I'm an advocate for battery storage. I'm looking at integrating that with my solar system on my house.
Oh, cool. Yeah.
Okay. I have solar thermal. I have solar PV. I have an EV in the driveway. But I'll never get rid of that natural gas connection because I know it's connected to the biggest, gaseous battery in the province. And from a cost perspective, for heating energy, you can get a kilowatt hour of storage for 1/3 of a penny. So I'm just going to leave that with you for a moment.
Yes.
You can figure out how to cut that penny into thirds.
It's an American penny as well, so that's good. Okay.
Now take the battery storage that I will probably invest in for my house.
Yes.
Let's say it's a 10 kilowatt hour battery. Let's say it has 10,000 cycles over its life, 100,000 cycles.
Yes.
I'm probably going to have to invest $7,000 to $10,000.
Wow.
I can get that same storage out of the gas grid for $350.
Wow.
You just should not ignore that type of economics. The environmental piggy bank is only so big.
Yes.
If we really care about decarbonizing the economy, figure out how to use everything that we have first before we build new.
So then, you walk around, you go to conferences and everything. We had Richard and Tim in here, and it's all about electrification, right? And electric vehicles and electric heating and on and on and on. And in a green grid like we have, it kind of makes sense. But why? I also get the penny analogy. Why are we not seeing a huge uptick of power to gas?
I think let's be fair. It's not just power to gas. It's why do we make the assumption that if we are going to bring renewables to the consumer, everything needs to come in electric?
Yes.
The idea of renewable pipeline fuels, renewable natural gas, hopefully we'll talk a bit more about that.
Yes.
Hydrogen that is either pumped directly to fill a vehicle as a fuel cell electric vehicle, injected in the pipeline, or stored until it can be brought back as electricity. Those kind of renewable fuels have not been part of our low carbon dialogue.
Yeah.
We've visually looked and said, gee, I can understand that solar panel. I understand that wind turbine. People may not like all those, that's debatable, but they at least understand that's renewable.
They're simple to get your head around.
Somewhere buried under the ground is all these pipeline networks, and they carry a lot of conventional fuels today.
Yeah.
But there's been a missing dialogue, and there's a number of barriers to this, but we need to embrace pipelines for renewable fuels like renewable natural gas, hydrogen injections, and supplies of things like conventional natural gas that we will decarbonize.
Yeah.
If we can actually take the carbon away as an environmental liability at the end use, now we've got something that cost-effective natural gas today without the carbon liability could also play a role. Why would we not embrace pipelines to supply that?
So we have simple to understand solar and wind. Everybody can get their head around it. We have electric vehicles, which are being marketed very well, and everybody gets it. And then we have pipelines that are, causing, railways to be shut down, and so how do we bridge that? The two couldn't be more far apart in terms of public perception. Where does that dialogue have to happen to actually, make it a reality?
So one from I think it's unfair to get the public to just say, all right, the light bulb went off, I get it. I think, energy policymakers, energy regulators, it starts with them engaging industry. So you've got one penny.
Yes.
Now I'm going to talk about the conventional costs of natural gas, renewable natural gas, and electricity, because this is where I think we can start to get the consumer on side.
Totally.
But the first thing before we talk cost is we need to get energy regulators and the industry policymakers talking in terms of cost in equivalent terms. In Europe, they sell gas by kilowatt or megawatt hours. If you were to offer consumers transparency, sell them electricity, sell them gas and common energy units, suddenly they would start to understand. So we hear a lot about, the natural gas range is going to disappear. Must go the way of the dodo because of carbon. Now, conventional natural gas for a kilowatt or for a kilowatt hour is going to be about 2 cents.
Okay.
Now, we've kind of eroded the Canadian penny, so you got 2 American pennies in your hand.
That's okay.
Now, we can add carbon costs to that and everything else, but a kilowatt hour delivered as natural gas will be about 2 cents.
Yes.
Renewable natural gas could be your green bin waste picked up at the curb, put through a technology called a digester, injected in the pipeline. There's all sorts of other innovations to bring renewable natural gas.
Yes.
But let's start with that one. Well, that might double or more than double the price.
Okay.
Maybe that kilowatt hour costs a nickel.
Yes.
Today, I can open up my electric bill, and on-peak electricity is going to cost 20 cents. So we've got a problem here.
Yes.
People look at the cost of renewables and say, solar electricity, wind, it's coming down. The benchmark is conventional electricity. We look at renewable natural gas, and people want to compare it to conventional natural gas. Wrong benchmark. You cannot compare renewable gas to conventional fuels. You compare the renewables to the renewables. So even if gas today was 4 times, renewable natural gas, if it was 4 times the price of conventional gas,
Yes.
it would still be as or more cost effective than me buying off-peak electricity in this province.
Wow.
Now there's one more piece that the policymakers need to get their heads around. Then we can educate the public. If we believe, like your trip to Denver, engaging the universities, everyone talking about a decarbonized economy, yeah, the cost of the renewable energy matters, the commodity. But I would argue that the only cost that matters going forward is what I'll call all in. It must be the commodity. It must be the cost to transport and distribute by wire or pipe. And it better include the cost of storage. And the moment you add all that together, you are compelled to look at how we diversify our renewable energy supplies to be, yes, decarbonized electric grids, decarbonized pipeline grids, decarbonized transportation fuels. And at the nexus of all that, or the hub, as we talked earlier, could be hydrogen. Could be renewable natural gas.
Yeah.
But at the end of the day, diversity and keeping economics at the forefront is going to matter. And so if you could supply your range and your dryer with renewable natural gas for what in this province is probably a 50% savings, and you're guaranteed to have renewable energy to those large plug loads, you just switch them to gas. And your biggest plug load showing up is likely the EV in your driveway.
Yeah.
That's my biggest plug load. Now, I love that EV, but I also make a habit of never plugging it in the daytime on-peak period. If I'm going to drive an EV, it has a range extender. And the moment I run out of juice, I'm not putting the burden of that load on the electric grid.
Okay, interesting.
Now, it's interesting because, probably November of this last year, the U.S. Thanksgiving holiday, the newspapers were alive with all sorts of photographs and write-ups of various electric vehicle owners lined up in large queues at charging stations. I paid a little attention to that.
Okay.
Counted up the number of charging stations that are what they call level 3. Now, those typical level 3 chargers are about 250 kilowatts each.
Okay.
Plug 2 cars into them, hammer the electric juice into that battery as quick as you can.
Yes.
It's still queuing up cars. But what the policymakers haven't wrapped their heads around, and this is why hydrogen, I think, will also be part of the story. They had 15 level 3 charging stations in there. At 250 kilowatts, that's over 3 megawatts of demand.
Yes. Wow.
Now, they will argue that, well, it's not always 250 kilowatts, but I've seen the argument that, gee, in order to get these queues and lines of people reduced, what we're going to have to do is start saying maybe they only get 80%, and that way we're maximizing the peak charging load and delivery, and then move them on to the next charging station.
Oh my.
Or we'll do something like bring in batteries to then backstop the charger.
Yeah.
Well, now suddenly I'm losing energy in the battery, I'm losing some energy in the vehicle. You're starting to get to the point where, all right, my biggest concern is Ontario on our 400 series highways.
Aha, right.
Our en route stations. You go on a long distance travel, you've got probably 15 gas and diesel pumps. It's going to take more than that in level 3 chargers with full transformation to that future economy that's decarbonized. Start adding up those 22 en routes alone, and you're probably into 80 to 90 megawatts of power.
Wow.
You're at the point of knocking on the door of a small gas plant in order to run that on-peak period.
Yeah.
Now think of what Toyota, Daimler, Hyundai, some of these companies that are diversifying with fuel cell electric vehicles, plug-in electric, hybrids, dedicated electrics. If we can take hydrogen and through power to gas get that in the off-peak period, now we can store as much hydrogen as needed for that next day's cycle.
Yeah.
Better yet, I can give you all sorts of technologies that diversify how we get the hydrogen and leave the environmental liability of carbon still dealt with. So we now, in the transport sector for fuel cell electric vehicles, can diversify how we get lower zero carbon hydrogen. And now you'd have, again, a portfolio. Plug-in EVs, hydrogen fuel cell vehicles, etc.
So on that last piece, is there still a competition in terms of, or are there still, I mean, everybody knows about Tesla and all the, the Chevy Bolt and all that stuff, but are there still kind of big car makers making a hydrogen, you said a couple of times hydrogen electric vehicle. Talk to me, what's that drivetrain look like?
I mean, it's probably very similar to the Chevy Volt that I drive. So,
that's okay.
Rather than a dedicated electric, I've got about 18 kilowatt hours of battery. I've got a small range extender engine. And when the battery runs out of juice, the engine's charging that battery. Now, many people will frown on that. But when you look at that vehicle, that's basically a platform ready for that small range extender engine and my gasoline tank to be replaced by a fuel cell and the hydrogen tank. Now, some would say, oh, well, that's a lot of complexity. I argue that if you are so simple on the platform that people are driving, but you back all the complexity up into the energy delivery network, that's one way of doing it. The other way is to give consumers what they want today, which is 5 minutes to fill a vehicle if and when they run out. And the reality is the convenience of plugging in at home. You could have that fuel cell electric vehicle with a very modest battery.
They
could do a plug-in at home for probably 80% of their driving. And when they do hit the highways, you know that, with a reasonable infrastructure for hydrogen refueling, people are going to be able to fill in 5 minutes, move on their way, and the carbon is going to be dealt with because a lot of that hydrogen is sourced through off-peak periods or by ways that will use, hydrogen production and sequester the carbon.
And that delivery, though, so let's go back to the en route. If the en route has a hydrogen infrastructure, that infrastructure is not leveraging the natural gas grid. That's a dedicated infrastructure, is that right?
I'd say you could have flexibility. So today in Europe, a lot of the fuel cell stations, or even in California, a lot of those hydrogen stations for fuel cell electric vehicles, they'll truck in hydrogen the same way they truck in gas and diesel. In some cases, they'll put power to gas electrolyzers on site and have on-site generation of the hydrogen from the electric grid.
In off-peak hours.
And be able to manage that, hopefully, to off-peak or, periods where the electric grid is zero or low carbon intensity. And then there are technologies that are here today but need some bolt-ons. So the largest supplies of hydrogen are from what they call steam methane reforming of natural gas. probably one of the most cost-effective ways to deliver hydrogen without carbon in the near to medium term is what they call blue hydrogen.
Okay.
We'll take that steam methane reformed hydrogen,
yes,
which produces almost a pure CO2 stream.
Okay.
And rather than vent that to atmosphere, capture it, sequester it, or hopefully start to use that carbon in various manufactured goods.
Aha.
Could be put into cement,
yes,
could be put into a number of chemicals, a number of feedstocks, and there are technologies that are now doing thermal cracking. So natural gas is fed in. They will use electroplasma systems from microwaves and basically break the carbon of natural gas away from the hydrogen. The hydrogen's recovered, the carbon drops out as solid carbon.
Whoa.
That solid carbon is now used to manufacture graphite, carbon black, used in the iron foundry industry, manufacture of batteries, printing inks. These are the things that are not being explored because we have said the only way forward is to electrify everything.
And that's what you call blue hydrogen.
Blue hydrogen.
As opposed to the power to gas is green hydrogen? Is that the terminology?
If your supply of electricity is renewable, then it would be green. And I think the market is certainly big enough for both.
Right.
What you're starting to see from the thought leaders out of Europe and others that have spent time looking at this,
yes,
they can accelerate the end user adoption of hydrogen systems by delivering the most cost-effective hydrogen from natural gas and paying a small fee to permanently sequester the carbon or derive it through carbon in other uses like the methane cracking I talked about.
You mentioned the methane reformer. So is that the tie with Air Liquide? Like I've been to the Air Liquide plant in Hamilton, and they have a steam methane reformer there. So are they? And I think they're doing it because their clients need both hydrogen and CO2 for whatever reason, or they sell CO2 to somebody. But maybe that's the tie with Air Liquide and some of this industry. But are they? Is that kind of the model where you take a steam? They're doing steam reformation now, and they would just do it in a bigger way and capture the hydrogen and figure out how to deal with the CO2. Is that?
Yeah, so this becomes that next stage of innovation. Okay. I'd say in Canada, the biggest short-term opportunity for zero or low carbon hydrogen using steam methane reformers and carbon capture is Alberta, because they have built proficiency at capturing carbon and storing that permanently underground.
Okay.
Here in Ontario, we may not have the same geology, but we have other opportunities because of our manufacturing base. So where Alberta might say, we're going to use the steam methane reformers, capture the carbon, put it underground, and send the hydrogen to other markets.
Yes.
Here in Ontario, we would use the steam methane reformers, capture the carbon, and figure out how the carbon is then converted or upgraded into various goods, carbon capture and utilization, rather than storage.
Okay.
So whether it's converted into chemicals, whether it's put into concrete, whether it's other permanent aspects like the methane cracking I spoke of,
yes,
a lot of that carbon black is in the rubber that is on every tire that is rolling down the highways today.
Interesting.
So you've got all these permanent storage pathways for carbon that show up in manufactured goods. That's where I'd say the opportunity for Ontario would be. And what is not well understood, everyone thinks, gee, Alberta, oil and gas, well, they must have the largest refinery sector. No, in Canada, the largest refinery sector is here in Ontario.
Wow.
So when you start to look at how you push adoption, or scale up would be a better way. What could we do to encourage refiners who use a lot of hydrogen today to scale up and bring the cost down a lot of our low carbon hydrogen opportunities and green hydrogen, and then shift that to mainstream adoption in other parts of the economy.
And you mentioned this carbon capture thing is interesting. Did I also hear you say at some point that carbon capture can happen on the back end? Like you mentioned it in the context of conventional natural gas as well.
Yeah.
Did I understand that correctly?
So anything that would be, let's say the power to gas with renewable electricity is our green hydrogen.
Yes.
Conventional hydrogen from natural gas sometimes gets called gray hydrogen.
Okay.
Okay. And then when we use that production method of natural gas in a steam methane reformer to hydrogen,
yes,
and then fit that with carbon capture
yes,
and storage, yes, that would become the blue hydrogen.
Okay.
Or, as I had mentioned, the other way to get blue hydrogen, again, you've got cost-effective conventional natural gas as the feedstock. You put it into some of these thermal cracking devices,
yes,
and you get two products. You get zero carbon hydrogen, high value, used in a number of areas. You get the carbon solids as carbon black, graphite, or other products that then go into high value manufactured goods.
Yeah.
And you're seeing awards out of places like Germany for some of the innovation, research, and development that's being done on things like thermal cracking.
Okay. Wow.
Solar fuels.
Yeah. Yeah.
In some cases, they're using high intensity solar collectors.
Yes.
To concentrate enough heat energy,
yes,
that it'll crack conventional natural gas with
Whoa.
No other inputs.
Whoa.
Now,
wow.
If you really want to take things for renewable natural gas,
yeah,
we could start talking artificial photosynthesis.
Mm.
So today, renewable natural gas might be landfill gas,
yes,
cleaned up.
Yes.
Could be green bin wastes collected at the curb, converted into pipeline quality methane.
Yeah.
But I can tell you that in different parts of the globe, they are looking at replicating photosynthesis and converting energy from the sun,
yes,
into basically liquid and gaseous renewable fuels. But what's not understood is that even close to home, University of Toronto has 2 professors that are leading some first-rate research into the development of solar fuels.
Wow.
And if you really believe that that's where we could be headed, you need things like pipelines to move that energy and store it.
Yeah. Wow. So let's talk a bit about RNG. Like I can take a bunch of stuff, a bunch of different forms of renewable natural gas, but what's your view on the outlook, in Canada, maybe specifically in Ontario, on where are we going with renewable natural gases?
I think we're just scratching the surface. I mentioned the barriers to renewable natural gas are its perceived cost premium.
Yes.
And again, we got to stop using the benchmark comparing to conventional fuels. Renewables only get compared to renewables. So once we can get our heads around that, I think the opportunities for renewable natural gas become much greater. Let's take advantage of the low-hanging fruit. If we've got landfills that are being flared, if we've got landfills where they're currently taking the gas and generating electricity, but at only about 40% efficiency, let's get those migrated off and instead upgrade it to pipeline quality fuel, inject it into storage, hold it in storage until the time is right for highest return to the consumer and maximized environmental impact. Let's do what we can on green bin waste through anaerobic digesters, wastewater treatment plants that have anaerobic digesters, that raw biogas, clean it up to pipeline quality fuels and inject it. But the real opportunity, once we understand the competitiveness of RNG, is on things like forestry wood wastes, other solids, municipal solid waste. Why do we even stick it in the ground and then hope we can devise a collection system to capture the methane, which is itself a more potent greenhouse gas, albeit for a shorter period of time than CO2?
Yes.
And instead put it into a device that will convert that to pipeline quality fuels. We have a plastics problem in this world.
Yes.
Now, plastics, well, some would argue, well, you don't want to turn that into fuel. That's not renewable. But what do we do today? We litter it across our landscape. It breaks down in the sun. It liberates gases that are a greenhouse gas warming agent. We, in some cases, landfill it and it just slows the process down. Or we do things like incinerate it. Now, That's assuming we haven't done our job recycling, but increasingly we're seeing challenges with recycling.
Yes, yes.
When those plastics from Asia were returned back to Canada, they ended up in an incinerator in Lower Vancouver. Now, I would argue that taking those plastics that we can't effectively recycle and converting that into a managed fuel is a far better way of dealing with it than bringing new conventional gas supplies out of the ground. We can now instead say, no, that plastic that was not recycled for whatever reason has been turned into fuel, managed, did not go to the atmosphere as methane. There are a whole bunch of benefits.
What's that technology piece there?
So we start to look at the next generation of renewable natural gas solutions.
Okay.
So these would be gasification systems.
Okay.
Or what's emerging is something called hydrogen reduction technologies.
Okay.
And this would be actually using hydrogen at the front end to help break down various organics and turn that into renewable fuels.
Okay.
These are right at the point of being demonstrated, piloted. I have every confidence that if we let the markets for renewable natural gas evolve, these technologies will become as mainstream as what solar production off people's rooftops is today.
Really? Wow.
But we need to remove those barriers to, a pipeline only carries conventional fuels. It's probably one of the foundational elements of our low carbon economy. And why? Because of that seasonal storage.
Wow, very cool. So what else, are there any technologies we've talked about that, or we haven't talked about, that you're excited about in terms of, this move to low carbon economy?
Yeah, I'd say from an end use, I'm waiting for my own house to be fitted with what is not well understood, but does exist. It's called a natural gas heat pump.
Okay, yes.
I'm very bullish on this technology. So in my own home, I've got the solar PV. I've got solar thermal. That's the priority to my domestic hot water and heating. When that doesn't work, I've got a high efficiency boiler that is making up the difference. What does exist but hasn't been brought to the mainstream is natural gas heat pumps. And like an electric heat pump, you're basically using ambient energy. And capturing that, and the efficiencies of natural gas heat pumps might be 130, 150%.
Wow.
U.S. Department of Energy has identified some technologies that they think could be actually well above that. But we've looked at it and said, well, natural gas is a conventional fuel. It's a problem. Why would I put that on? Think in terms of renewable natural gas. Now, even if I double or triple the cost in the early years of RNG, but I put a technology on like a natural gas heat pump, and it cuts the consumer's bill by 40%, I've given them a zero carbon opportunity to stay connected to our existing seasonal storage. It will be far more cost effective than trying to run very efficient electric heat pumps. And on top of the cost efficiency, those electric heat pumps in this province during a peak demand day will be running on marginal gas-fired electricity generation. So
there's the clinch.
We need to look at our energy more as an ecosystem.
So to do that, I think I heard you say this earlier, but if you were kind of premier for the day, I think I'm hearing you say you might do two things. You might look at everybody's bills for utilities and insist on a common unit of measure, whether it's kilowatt hour or gigajoule, but put everybody on the same metric. That's probably one thing.
That would be my mandate to the energy regulator. Now, we may not change the actual billing arrangement, but we would at least show on the bill what it is in equivalent terms.
And then the second piece would be, to start talking about the stacked cost of every utility, which I think I heard you say was the commodity, the carbon cost, and the storage cost. Are those the three kind of stacks that?
So carbon cost, I'll layer on to if it attracts carbon costs, which things like renewable electricity or renewable natural gas would not.
Yes, right.
So yeah, we'd end up with the commodity, distribution and transmission costs, and the cost of storage.
Right.
And I think to add to that, I think the first thing I would do, so let me put it in terms that I think many people understand. A lot of people in retirement planning will use an investment advisor. One would hope that investment advisor is recommending a diversified portfolio. If they came back and said your whole retirement plan is based on one stock,
right,
or you're only going to go in this one sector,
yes,
I'd fire said investment planner.
Right.
I think it's incumbent upon energy planners to, even if the line of sight to the end state is a little bit murky, diversity is key.
Yeah, keeping the options open.
And therefore, we need to be much broader in our approach. So while I fully support, decarbonizing the electric grid, I myself am practicing distributed energy resources on my own house. I am advocating strongly that a key part of this is to ensure that things like renewable pipeline fuels, hydrogen, they all need to play their role. And like your investment portfolio, the next year one sector might perform stronger than the other.
Interesting.
But we are going to see that ebb and flow through the different sectors. In my career, I've watched commodity prices for oil and natural gas and electricity change by factors that horrify consumers. And yet they find an equilibrium. But that would be the other reason to diversify. You don't want your entire economy bellying up to the bar for just one single commodity. Keep our renewable options open.
So in terms of, you mentioned a bit about what you're doing, our hope is that folks listening to this are, those who are, making or influencing decisions in large hospitals and universities and industrials and maybe some developers, but those who are, in this energy space, what are some things that they can be either researching or implementing or, getting to know more about? What are some actionable steps, as you see this? You talked about diversity in your portfolio. Are there other things that people can be doing to to be prepared for where we're going next?
I need to go back to our early discussions on energy efficiency. I don't care whether it's electric appliances, gas appliances, whether it's the efficiency of your heavy-duty trucking or your car. Double down on it. It's been proven time and time again that it's the most cost-effective way to manage energy costs and also, advance the lower carbon agenda. Once you've done that, I think, a university is a good example. They're facing a lot of pressure for people to say, you should not be investing in certain sectors. The oil and gas sector is part of that. In some discussions, it's about pipelines. I would rather see, if someone has a concern about pipelines, if they have a concern about fracking as one means of liberating that gas, rather than advocate against the infrastructure that is a solid return on how you would store future renewable energy, advocate for greater renewable supplies to fill that pipeline. So your universities could be at the forefront of purchasing renewable natural gas, hydrogen.
Is there a market clearing or some mechanism that facilitates that? Like, if I got employed by Brock University tomorrow, could I figure out how to buy RNG? I'm not getting the molecule, but I'm getting the...
It certainly for a sophisticated client like an industrial manufacturer, for a university, the tools are there for them to buy this. Now, we need to help even that sophisticated buyer understand, look, this looks expensive,
Yes.
compared to your conventional fuels, but your comparison is your option of other renewable things like renewable electricity. Then we can find the buying mechanism. Now, I will say the good news is provinces like Quebec and BC, they're at the forefront of actually providing far greater transparency and signaling that, renewable pipeline fuels will play a role in their economies.
Yeah.
We're not seeing as much in other provinces yet, but I'm hopeful that just getting this discussion started, they will start to understand that no matter what your political leaning is, it's probably incumbent on you to say, that diversified portfolio makes sense. I want to help move in that direction. And then, that signal can go to energy regulators. Energy regulators can start to say, okay, I'm going to open up a certain wedge of the market for that renewable commodity.
Yeah.
And then your mainstream utilities, other players in the market, they can provide the actual service to buy that renewable energy.
Right.
Today, it's not as transparent as it should be for the consumer.
Wow. Dave, this has been great. This has been really fun. Where can our listeners find you? What's the best way to, you have a website up and running yet, or how can they, you got so much, I'm sure the Ministry of Environment, Ministry of Energy are listening to this. Like, how can they get you in front of them to help them make these decisions? Where do we find you? Yeah,
with my new business, I've been trying to grow myself into the LinkedIn platform better.
Cool.
So first name David dash last name Tykerobe, and if they have that on the podcast as my last name, then looking for that on the LinkedIn platform will probably get them there to follow some of the future deliberations on energy I can offer.
Well, we'll make sure we link you, and we're big LinkedIn fans too, so we'll make sure we get you posted. And thank you for doing this. This is ultimately this is selfish for me. Like, I'm smarter as a result, and if somebody else listens to it and gets benefit, great. But this is mostly selfish for me. So I appreciate you kind of coming in and sharing your wealth of knowledge, but more importantly, your vision for where things are going. Martin has always described you as a visionary, and this last, I don't know what it's been, an hour or whatever, it clearly proves that. So thank you very much.
Well, Matt, just my appreciation to you and also CEM Engineering. I mean, getting these discussions started, expanding the dialogue to your customers and others that are part of your network. It's appreciated because at the end of the day, I'm a strong advocate for that decarbonized economy. I just want more tools to be used by everyone out there. And I think we've had a good discussion today on that. So my appreciation.
Yeah, and we're standing shoulder to shoulder with you in that whole fight for decarbonization. So thank you for listening to this episode of Energy Radio. This is episode 17 with David Tykerobe of EE Energy Advisors. Awesome. Thank you.
Thank you, Matt.
Cool. Thank you, sir. This was fun.
This was a great
time. Yeah, it was great.